Good day, learners! Welcome to the new episode of Math Corner. For today's video, I'm gonna teach you how to solve for x and y-intercept, as well as the vertical and the horizontal asymptote of a rational function. A rational function is denoted by f of x is equal to ax to the power of n over bx to the power of m, where n is the largest exponent in the numerator and m is the largest exponent in the denominator. Let's say, for example, we have here the rational function given 3x minus 1 over x plus 5. Now, we are going to determine the letter a, b, n, and m. So, we are going to determine the values of these letters. Now, we all know that a and b are the leading coefficients of both the numerator and the denominator. Now, as you can see here, since our given numerator is 3x minus 1 and the leading coefficient is the number 3, therefore, our a here is 3, which is the leading coefficient of the numerator. On the other hand, the leading coefficient of the denominator is 1, which is the coefficient of the variable x. That is why our b here is 1. How about letter n? Now, we all know that n is the biggest exponent of the numerator. Therefore, since the biggest exponent of the numerator is 1, which is the exponent of x, therefore, our n is 1. Which is the same with m, which is the leading or the biggest exponent of the denominator. Now, as you can see, our given denominator is x plus 5, and the biggest exponent of our denominator is also 1, which is the exponent of the variable x. Therefore, our m is also 1. Okay, how about the domain of this function? Now, we all know in the previous video, I already taught you how to get the value or how to get the domain of the different functions, including the rational function. Now, to get the domain of the rational function, just simply set the denominator equal to 0, which means that the denominator is equal to x plus 5, which is we have to x plus 5 is equal to 0. We have just to equate the denominator into 0 and then solve for the variable x. And then so we have here x is equal to negative 5, which means that our domain will be the set of all real numbers except negative 5. Next, x-intercept and y-intercept. X-intercept, it is a point where the line crosses the x-axis. At this point, y is equal to 0. To find the x-intercept, just set the numerator equal to 0 and simplify. Now, going back to our given rational function, which is 3x minus 1 over x plus 5, as I said, in solving for our x-intercept, we just simply set our numerator equal to 0. Now, since our numerator is equal to 3x minus 1, and then we have to equate that 1 to 0, which means 3x minus 1 equal to 0. And then solve for the variable x. That means we have 3x is equal to positive 1, divide both sides by positive 3, which means x is equal to 1/3. Now, as we all know, that in the x-intercept, y is equal to 0. Therefore, our x-intercept is the ordered pair 1/3, 0. How about in y-intercept? Y-intercept, it is a point where the line crosses the y-axis. At this point, x is equal to 0. The y-intercept is given by 0 and f of 0. Now, going back to our given function, 3x minus 1 over x plus 5, what do you think is the process in solving for our y-intercept? Now, in solving for our y-intercept, we are going to solve for the function f of 0. We are going to let our x, which is equal to 0. That means we have here f of 0 is equal to 3 times 0 minus 1 over 0 plus 5, which is equal to negative 1 over 5. Which means our f of 0 is negative 1/5. And since our y-intercept is given by the ordered pair 0 and f of 0, which means our x is 0 and our f of 0 is equal to negative 1/5. Therefore, the ordered pair 0 and negative 1/5 is our y-intercept. Asymptote, it is a line or curve that acts as the limit of another line or curve. There are two types of asymptotes. The first type is the horizontal asymptote. Now, in the given example, the graph or the asymptote of the graph is given by y is equal to 2. The second type of asymptote is the vertical asymptote. Now, in the given example, the vertical asymptote is given by x is equal to 3. But how can we solve the two asymptotes? First, how to find the vertical asymptote? To find the vertical asymptote, simply set the denominator of the given rational function to 0. Now, just like in solving for the domain of the rational function, we are going to set the denominator equal to 0 to solve for the vertical asymptote. Now, since our denominator is equal to x plus 5, that means we have here solve for, we're just going to use the abbreviation. We have here the VA, which means vertical asymptote. We are going to simply set the denominator equal to 0. We have x plus 5 is equal to 0. So x is equal to negative 5. Therefore, our vertical asymptote is given by the line x is equal to negative 5. How about our horizontal asymptote? How to find the horizontal asymptote? There are three cases to find the horizontal asymptote. First, if n is less than m, then the x-axis is the horizontal asymptote. If n is equal to m, then the line y is equal to a over b is the horizontal asymptote. Lastly, if n is greater than m, there will be no horizontal asymptote. Now, it is very important for us to remember the values of our n and m as well as a and b, which we already determined on the first part of our solution. So, we are going to go back to our values of n and m. We're going to look at the values of n and m. So, since the values of our n and m are both 1, therefore n is equal to m. Therefore, our horizontal asymptote is given by the line y is equal to a over b. So, we have here solve for HA, which is horizontal asymptote. As I said, since our n is equal to m, our horizontal asymptote can be determined by y is equal to a over b. Now, what are the values of a and b? A and b, going back to our values here, we have 3 for a over 1 for b, which means 3. Therefore, our horizontal asymptote is given by the line y is equal to positive 3. Since we already have the values of our vertical and horizontal asymptote, now we are going to put that one in our Cartesian plane. Now, for example, since our vertical asymptote is given by the line x is equal to negative 5, therefore, our vertical asymptote will be this line passing through x equals negative 5. On the other hand, our horizontal asymptote is given by y is equal to positive 3, which means this will be our horizontal asymptote, which is a line passing through y is equal to positive 3. Now, how does the graph of this rational function look like? Now, using this table of values right here, the graph of this rational function will look like this. So, there will be a graph right here, and the opposite of that graph will be right here. Now, as you can see, the graph of this rational function is just approaching the vertical asymptote and the horizontal asymptote, but it never touches. So if you're going to extend this one to infinity and this one to infinity, as well as the graph of this rational function, it gets closer and closer to the vertical and the horizontal asymptote, but it never touches both the asymptotes. Let's have the second example. Given the rational function, f of x is equal to x plus 12 over 5x squared minus 10x. Now, first thing to do is to determine all the values of letters a, b, n, and m. So, as we all know, a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. So, that means our a here is equal to 1, which is the coefficient of x. And then our b is equal to 5, which is the coefficient of the x squared. And n, as we all know, n is the biggest coefficient of the numerator. That means the biggest coefficient, the biggest exponent in the numerator is equal to 1, which is the exponent of x. That means our n is equal to 1. And m is the biggest exponent of the denominator. Now, as you can observe, the biggest exponent in the denominator is 2. So that means our m here is 2. Now, second step. How can we solve for the x-intercept? Can you still remember the process in solving for the x-intercept? That's great. Now, in solving for the x-intercept, we just simply set the numerator equal to 0. So, since our numerator is equal to x plus 12, that means x plus 12 is equal to 0. And then, so for x is equal to negative 12. Since this is x-intercept, as we all know, in the x-intercept, our y is equal to 0. Therefore, our x-intercept will be negative 12, 0. How about y-intercept? Now, as we all know, in solving for the y-intercept, we are going to solve for the function f of 0. That means we are going to substitute 0 in all the variable given, or all the x given. Now, if you are going to substitute 0 to the variables given, as you can observe, if you are going to substitute 0 in the denominator, both x squared and here x, our denominator will become 0. That means, in this case, there is no y-intercept. Because if we are going to solve for f of 0, our denominator will become 0. So in this case, the rational function has no y-intercept. Now, let's proceed now in solving for our vertical and horizontal asymptote. Let's solve first for the vertical asymptote. Now, how can we solve the vertical asymptote? What is the process again? Okay, in solving for the vertical asymptote, just like in solving for the domain, we are going to set our denominator equal to 0. So since our denominator is equal to 5x squared minus 10x, now, as you can observe, if our expression can still be factorable, we are going to factor, or we are going to get the factors of our denominator, or of our expression given. So we have here, we can factor this one into 5x times x minus 2, which means we already have two factors, and then we are going to equate each of the factor equal to 0. That means 5x is equal to 0, and the other one is equal to x minus 2 equal to 0. And then here, x is equal to 0, and x equals positive 2. Therefore, yes, it's correct. There are two vertical asymptotes in this given rational function. One asymptote is given by the line x is equal to 0, and the other asymptote is given by the line x is equal to positive 2. How about our horizontal asymptote? Solve for horizontal asymptote. Can you still remember the three cases in the horizontal asymptote? That's great. Now, in solving for the horizontal asymptote, what did I say? We need to go back to our previously determined values of our a, b, n, and m. Especially the n and m. Now, as what you can observe, our n is 1, our m is equal to positive 2. Now, it is very obvious that our n is less than m. That falls to our case number 1, which is, if n is less than m, then the x-axis will be the horizontal asymptote. Therefore, without any solving, our horizontal asymptote will be the x-axis, because our n is less than m. That is in the case number 1. Now, how does the graph of this rational function look like, considering our vertical and horizontal asymptote? Now, first thing to do is we are going to put our horizontal asymptote and vertical asymptote in our Cartesian plane. So since our vertical asymptote, as you can see, there are two vertical asymptotes given. So the other one is x is equal to 0, and the other one is x equals positive 2. So we are going to put first x is equal to positive 2. So the first vertical asymptote is given by the line x equals positive 2, which is a line passing through positive 2. And the other vertical asymptote is given by the line x is equal to 0. That means here is our vertical asymptote, or simply the y-axis, which is equal to x is equal to 0. And how about our horizontal asymptote? Our horizontal asymptote is our x-axis. Therefore, this one right here is our horizontal asymptote. Now, how does the graph of this rational function look like? Now, there are three partitions in our Cartesian plane. One graph is on the right side of positive 2, the other graph is on the left side of 0, and the other graph is in between 0 and positive 2. So if you are going to put this table of values in our Cartesian plane, so use these values in the table of values here, the graph of this rational function will look like this. So one graph will be here. The other graph of this rational function located here. And the other graph, as what you can observe, as I said, there are three partitions. The other graph is in between 0 and positive 2. Therefore, the other graph will be right here. So, the same with the previous example, as I said, as what you can observe, the graph of this rational function is just simply getting closer or approaching both the vertical and the horizontal asymptote, but it never touches. Even if you're going to extend both the vertical and the horizontal asymptote into infinity, and at the same time the graph of this rational function, still it never touches both the asymptotes, but it gets closer and closer, but it never touches. Okay.